Assalamu alaikum and hello everybody, welcome to Maths April. Today we will be doing transformation, so let's start with this new chapter. There is a general formula you need to revise for this chapter, which is y is equal to a times x minus h whole square plus k, where a is the stretch factor, meaning by how many units the x or y coordinates have been stretched. H is the horizontal shift, meaning by how many units the x coordinates have been shifted along the x-axis. K therefore is the vertical shift, meaning by how many units the y-coordinates have been shifted along the y-coordinates. There are three basic transformations we will be devising for this chapter, which are translation, reflection, and stretch. These are all the possible equations of translation, reflection, and stretch. So the first one being y is equal to fx plus a. Keep in mind if a or any factor is or coefficient is outside the bracket, hence outside f of x, means that the y coordinate are changing. However, if it is inside the bracket, so x plus or minus a or ax or minus ax, it means that the x coordinates are changing. So for this first one, the transition is by the vector 0 and a. A is the y value. So a is changing the y value or the y coordinate. The second one, it's the same. Y is and the third one, y is equal to f into x plus a. This time the x coordinate are changing because it is inside the bracket. So translation by vector negative a, 0. It is negative because the original equation is x minus a. So minus minus plus is plus. Hence there, in this case, a is negative. Vice versa for the fourth equation. And then moving on to reflection, y is equal to negative f of x, meaning that the y values are changing. Hence, if the y values are changing, if at first it is minus 4, minus fx makes it plus 4. So it is changing at the line of reflection x is equal to 0, or you can say along the y-axis. And in the second case, y is equal to f into minus x, the x coordinate are changing, hence the line of reflection is y is equal to 0. Moving on to stretch, y is equal to af of x. So the stretch factor is a, and the y-axis are changing along y-axis. Sorry, the y-coordinates are changing along the y-axis. In the second case, y is equal to f into ax. The stretch factor in this case is 1 over a. This is an exception to the general formula. If it is a into x for along x-axis, the stretch factor, we take it as 1 over a. So let's suppose the stretch factor in this case is 4. So we would write it as stretch factor 1 over 4 and vice versa. Now let's move on to an example. So for example, if there is a question and it asks us to state the transformation, the type of transformation, and the new equation. So in this case, the initial equation of this graph was y is equal to f of x, or y is equal to x. And now, as we can see, the stretch factor remains the same as the length of both the lines are the same. There is no reflection also, as both the lines are parallel. Hence, this is a transition along y and x-axis, as both the coordinates have changed. This point on the first initial graph is 1, 1. The first point on the final graph is minus 11, 3. So the transition vector would be by 2. It has moved 2 units towards the right, so 1 and 2. So plus 2 along the x-axis, and along the y-axis it has moved from 1 to minus 11, so minus 12. However, you would expect it to be f of x plus 2, but as the general form as x minus a, it would be x minus plus 2 minus 12. And the final equation would be f of x minus 2, so x minus 2 minus 12. Whenever the translation along the x-axis is positive 2, in the equation we write it as negative 2. You already know the reason, as the general form is x minus a. If the original translation along x-axis is minus 2, we write it as plus 2 in the equation. The y-axis translation stays the same. If it's minus 12, we write it as minus 12 outside the bracket. So there we have it. Let's move on to this example where the question asks us to state the transformation again and the equation, the new equation. So YH, the non-dotted line, is transformed to YG, which is the dotted line. And we have taken two common points which have been reflected in this case. We judge that, or we assume that as this part of the graph has moved towards the left. So it has reflected on this line. X is equal to minus 4. So this is a straight line, a straight vertical line on x is equal to minus 4 along the x-axis. As the x-axis has changed from minus 2 to minus 6, the y-axis remains the same, so it has reflected by the line of reflection x is equal to minus 4. So the new equation would be f of minus x. Now let's move on to another transformation question. This is an isosceles triangle A and B. As we all know, this isn't the equation of an isosceles triangle, but as an example, or to get an idea of this transformation, we can use this general equation. In this case, as you can see, the point 21 and the point 61 remains the same for both the triangles. However, this point is changing from A to B. The x-axis remains the same, 4 and 4. However, the y-axis changes from 3 to 9. Hence, there is an increase of 3, as 3 times 3 is 9. So that is our stretch factor. So times 3. As it is along the y-axis, we would write it outside the bracket. 3x whole square. There is no vertical or horizontal shift, meaning this would be our final equation of graph B. We are now done with transformations. Hopefully you understood what I have taught, and so have a great rest of your day, and Assalamu alaikum.